Good morning, my dear children. Today we are going to discuss about that. What are the properties of inert gases? That is group 18, inert gas element. What are the properties? That means physical properties and chemical properties. What are the physical and chemical properties of inert gases? There is a unit number 3, P block element 2, and the page number is 92. Unit number 3, P block element. Okay, P block element 2. Okay, here what are the physical and chemical properties? Already we know that on the noble gas or inert gas or rare gas, these are all monoatomic, that is helium, He, neon, Ne, argon, Ar, krypton, Kr, xenon, Xe, am I right? These are all what? Monoatomic. Next about the colorless, these are all colorless, odorless, tasteless, and also non-inflammable gases. Am I right? These are all non-inflammable gases. They are highly unreactive element. They are also non-metallic in nature. What about the chemical properties? We can be discussed about the chemical properties. Only xenon and krypton show some chemical reactivity. That means neon, argon, krypton, xenon and radon. Out of these, only xenon and krypton show some chemical reactivity. That is xenon fluoride. We can be prepared xenon fluoride by the reaction between xenon reacts with fluorine. We get xenon fluoride under a different condition. Different condition means, what are the condition here means? One is we are using nickel as a catalyst, and also we are giving 400 degrees Celsius, and also acetone with nickel 400 degrees Celsius. Nickel with 200 atmospheric pressure, and also we are using 400 degree temperature. Am I right? These are the certain conditions we have to apply here. First, the reaction. How is xenon difluoride prepared? In between the reaction between xenon and fluorine, what's the symbol of xenon? Xe, and about the fluorine F2, Xe plus F2, we get xenon difluoride. The presence of nickel as a catalyst. What is the symbol of nickel? Ni, nickel as a catalyst, and also we are applying 400 degrees Celsius. Now the equation is balanced. What about the second one? Xenon reacts with the fluorine. It is Xe plus F2 gives in the presence of Ni and acetone. All of you know the formula of acetone, that is CH3COCH3. Am I right? Dimethyl ketone, acetone. The temperature is about 400 degrees Celsius. We get xenon combines with the fluorine. We get xenon tetrafluoride. Tetra means 4. So XeF4, that is xenon tetrafluoride. How can we balance the equation? The product said we are having 4 fluorine. So make it 2 here. If you have 2 F2 means it is balanced. Now, how is xenon hexafluoride prepared? That is xenon reacts with the fluorine in the presence of nickel, and also we are applying 200 atmosphere, and also we are applying here 400 degrees Celsius. We get xenon hexafluoride, XeF6. How can we balance the equation? The product side here having 6 fluorine, so make it the reactant side 3F2. Now the equation is balanced. Next, how XeF6 on heating at 50 degrees Celsius in the presence of silica, which product is formed? That is the important point. That means, how is xenon oxytetrafluoride prepared? That's a question. How is xenon oxytetrafluoride prepared? Okay, what's the formula? XeOF4. So how can we prepare means? By the reaction between xenon hexafluoride. What is the formula of xenon hexafluoride? XeF6 plus silica, that is SiO2, we are giving the temperature, it is about that 50 degrees Celsius, we get one of the product called xenon oxytetrafluoride. What is the formula here? XeOF4, XeOF4, that is xenon oxytetrafluoride. And also one of the silica combines with the fluorine, we get SiF4, SiF4, silica tetrafluoride. How can you balance the equation? So here the silica, that is a reactant side having silica, oxygen 2. So make it the product side 2 oxygen, that is 2XeOF4. Am I right? If you are making 2 here, means oxygen is balanced. What about the xenon in the reactant side? That also make it 2. Now the equation is balanced. Am I right? Next one. How xenon oxyfluoride reacts with the silica? Xenon oxyfluoride reacts with the silica. What is the formula of xenon oxyfluoride? XeOF4. XeOF4. This xenon oxyfluoride on reacts with the silica, that is SiO2, we get XeO2F2, XeO2F2, that is xenon dioxide difluoride. What is the name? Xenon dioxide difluoride. And also the silica combines with the fluorine, we get silica tetrafluoride, that is SiF4. So how can you balance the equation? The reactant side they're having 3 oxygen, the product side having only 2 oxygen. So make it 2 in the product side, that is 2XeO2F2, 2XeO2F2. So now the oxygen become 4. So make it the reactant side 2XeOF4, 2XeOF4. So now the oxygen is balanced. What about the xenon? Xenon is also balanced. What about the fluorine? Fluorine is also 2 into 4 is equal to 8. Here also 4 plus 4 is equal to 8. Now the equation is balanced. Next about this xenon dioxide difluoride. Xenon dioxide difluoride again reacts with the silica, that is SiO2, that is XeO2F2, and reacts with the silica SiO2, we get XeO3, and also the silica combines with the fluorine, we get SiF4, silica tetrafluoride, and also we get xenon trioxide. What is the name of the compound? Xenon trioxide. Tri means 3 oxygen, am I right? Xenon trioxide, and also we get silica tetrafluoride. How can you balance the equation? The reactant side they are having 4 oxygen, but the product side they are having only 3 oxygen. The reactant side we have 4 they have only 3. So if you are making 2 on the product side, means 2 3s are 6 oxygen. So here also if you are making 2 on the xenon dioxide difluoride, 2 means 2 2s are 4, 4 plus 2 6. Now the oxygen is balanced. What about the silica? Silica also balanced. What about the fluorine? Fluorine 2 2s are 4. Here also 4. So the equation is balanced. Am I right? Next question, that is about that. What happens? Xenon hexafluoride on reacts with water, undergoes hydrolysis. That is xenon hexafluoride undergoes hydrolysis. So what's the product is obtained? That is xenon trioxide is obtained. Xenon trioxide is obtained. That is, we can write the equation XeF6. What is the name of the compound? XeF6. That is xenon hexafluoride on reacts with water H2O. We get XeO3. XeO3. What's the name of the compound? XeO3. Xenon trioxide, and also the hydrogen combines with fluorine, we get HF. So how can you balance the equation? The product side here having XeO3, so make it the reactant side 3 water molecules. Oxygen 3, so make it 3 water molecules. Now how much fluorine is there? Xenon XeF6, 6, so make it the product side also 6HF. Now the equation is balanced. Next, one of the important question. one of the important question. What happens? Xenon hexafluoride reacts with sodium hydroxide. What happens? Xenon hexafluoride reacts with the sodium hydroxide. So we have to write the equation. Xenon hexafluoride, that is XeF6, on reacts with the sodium hydroxide, that is NaOH, we get sodium perchenate. Sodium perchenate. So here we are using xenon hexafluoride reacts with the sodium hydroxide. We are using 2.m sodium hydroxide, sorry, 2.5 m sodium hydroxide. We get sodium perchenate. Sodium perchenate is obtained. What is the formula of sodium perchenate? Na4XeO6. Na4XeO6, sodium perchenate. And also we get xenon, that is Xe, and also sodium combines with the fluorine, we get NaF, and hydrogen combines with the O to form water molecules, and also we get oxygen O2. So xenon on reacts with the sodium hydroxide at 2.5 m sodium hydroxide, we get 5 different products. One is about that sodium perchenate, that is Na4XeO6, and we get xenon, that is Xe, and also sodium fluoride NaF, water molecule H2O, and also we get oxygen O2. This is the product. Am I right? So how can you balance the equation? Balancing the equation is very, very important. One of the very important questions. Try to balance the equation. The product said how much is xenon is there. Here having one, here having one. So 2 xenon is here. So make it the product said also. So reactants will also make it 2XeF6. 2XeF6 xenon hexafluoride. So come to the fluorine. How much fluorine is there? 2 into 6 is equal to 12 fluorine. So make it the product said also make it 12 NaF. 12 NaF. So fluorine is balanced. Next come to the sodium. Here having 12 Na, here having 4 Na. So 12 plus 4 is equal to 16 sodium. So make it the reactant side 16 sodium. So now sodium is also balanced. So what about the hydrogen? Here 16 hydrogen having, if you are making the 8 H2O means now water 8 H2O means water is also balanced. Next one of the important properties is sodium perchenate is one of the strong reducing, it shows one of the strong reducing property. How can we explain about the sodium perchenate? Is much known for strong not reducing property, oxidizing property, not reducing, oxidizing property. That is, what is the reaction is going on here means, the 11th grade we learn about that ion electron method, one of the method. That method only we can be balance this equation. How can we balance this equation means, 11th standard we thoroughly learn about that, how to balance in ion electron method. First, we can be write the try to learn about that manganese, that is manganese Mn2 plus ion. Am I right? Loss of 2 electron. This manganese Mn2 plus ion is converted into MnO4 minus ion. Manganate, that is permanganate. Am I right? Potassium permanganate. What is the formula? KMnO4. Am I right? Potassium permanganate. Here Mn2 plus is converted into MnO4 minus ion. So what is the oxidation state? You have to find the Mn oxidation state. So I am taking Mn is taken as a X. So X, am I right? Mn is taken as X. Otherwise we can be, first you have to write KMnO4. That is very easy. KMnO4. Potassium, that is one of an alkali metal. Hydrogen, sodium, potassium, these are all what? Plus 1 value, am I right? So I am writing plus 1 plus Mn I am taking as X. So plus 1 plus X plus oxygen, all of you know that one, the value is minus 2. So 4 oxygen is there. 4 into minus 2 is equal to 0. 1 plus X, 4 into minus 2 is equal to minus 8. So 1 plus X minus 8 is equal to 0. X is equal to 7. So MnO4 minus the oxidation state is about that plus 7 oxidation state. I'm right. That is plus 2 oxidation state is converted into plus 7 oxidation state. That is one of the reaction. Next about we can be right. XeO6 4 minus XeO6 4 minus. This is converted into XeO3. So how can you balance? How can you find the oxidation state of Xe? Xe means it can be taken as X xenon. Xenon means you are taking X plus how much oxygen is there? 6 oxygen. So make it 6 into oxygen is minus 2. 6 into minus 2 is equal to here having 4 minus. I am giving here also minus 4. So X plus 6 minus 2 is equal to minus 4. X minus, that is 6 into minus 2 is equal to 12. So minus 2, that is, sorry, minus 12. X minus 12 is equal to minus 4. X is equal to minus 4 plus 12. So we get X is equal to plus 8 oxidation state. So the XeO6 4 minus the oxidation state is plus 8. It is converted to XeO3. What is the oxidation state of XeO3 for xenon? That is xenon I am taking as X plus 3 into oxygen is minus 2 is equal to 0. That is X is equal to X minus 6 is equal to 0. X is equal to plus 6 oxidation state. Am I right? So then how can you easily solve this equation? Means first I am going to write about that XeO6 4 minus here having plus 8 oxidation state, but the product side they are having plus 6 oxidation state. So electron here having excess, so I am taking 2 electron minus plus 8. I am taking 2 electron minus, that is plus 2 electron minus, and I am giving H plus ion because it is one of the reaction is going on with the help of in the presence of sulfuric acid, H plus ions. So I am using H plus ions. We get xenon trioxide XeO3, and also this hydrogen combines with oxygen, we get water molecules. Am I right? Water molecules, H2O. So how can you balance the equation? What's the easiest way? This XeO3 becomes plus 6 oxidation state. Am I right? So how can you balance the equation? The product side they are having 6 oxygen. Sorry, the reactant side they are having 6 oxygen. So come to the product side they are having only 4 oxygen. If you are making 3 water molecules means now oxygen balance. What about the hydrogen? 6 hydrogen having. So make it reactant side also 6 H plus ions. Okay. Now the equation is balanced. So how can we balance the next step? Next step is how can we write the full equation? That is one of the important. Just I am taking only for the understanding, okay, not for the examination point of view, just for the understanding and also just for the other examination, maybe NEET examination, JEE examination, or maybe IIT examination. That time you can be use this question. Okay, so please watch carefully. First, what happened here means Mn2 plus ion, that is Mn2 plus, and reacts with water, that is H2O, we get MnO4 minus plus here Mn2 plus, that is Mn oxidation, that is Mn2 plus is converted into plus 7 oxidation state. That is MnO4 minus ion, we know that one, plus 1 oxidation state. Mn2 changed to plus 7. So here also having 5 electron variation. Right? There is a 5 electron difference. Here the reactant side plus 2, the product side plus 7. So I am take the 5 electrons minus, I am minusing the 5 electrons, is plus 5 electron minus. Okay. So water. The water molecules are having H plus, am I right? So make it I am here H plus ions. So how can you balance the equation? In the product side, how much oxygen is there? 4 oxygen, am I right? MnO4, that is 4 oxygen. So come to the reactant side. I am making here 4 water molecules. Now oxygen is balanced. What about the hydrogen? 4 into 2 is equal to 8 hydrogen. So I make it 8 H plus ions. Am I right? So now the equation is balanced. Second step, I am taking XeO6 4 minus ion. XeO6 O6 4 minus ion. We find that on the oxidation state is about the plus 8. It is converted into XeO3. Am I right? XeO6 4 minus is converted into XeO3. Okay, so here also we have to write the presence of H plus ions. So H plus ions in the reactant side, it is converted into the H combines with XeO6, the oxygen having, so make hydrogen combines oxygen, we get the product H2O. So we get water molecules. Am I right? So listen all of you. Here the first oxidation state is plus 8 is changed to plus 6. What is the xenon trioxide oxidation state for xenon means? You have to find out that on XeO3. X I am taken as X plus how much oxygen is there? 3 oxygen. So make it 3 into minus 2 is equal to 0. X minus 6 is equal to 0. X is equal to plus 6 oxidation state. My dear children, in the reactant side they are having plus 8 oxidation state, but the product side having plus 6 oxidation state. So the difference is 2 electron, am I right? So in the reactant side I am writing here XeO6 4 minus plus 2 electron minus, am I right? Because the product side having plus 6 oxidation state. So the difference is I am writing here 2 electron minus. Okay, now plus H plus ions gives XeO3, that's oxidation state is plus 6, and also we get water molecule H2O. Am I right? Yes or no? So how can you balance the oxygen? The reactant side having 6 oxygen, the product side having only 3 oxygen. If I am making 3 water molecule means oxygen is balanced. Yes or no? 6, 6. Am I right? What about the hydrogen? Here 3 H2, that is 6 hydrogen. If you are making 6 H plus means that equation also balanced. Now come to the point. This equation, this first equation, that is Mn2 plus ion 4H2O gives MnO4 minus plus 5 electron minus plus 8H plus ion. I am multiplied by 2. This equation I am multiplied by 2, and the below equation I am multiplied by 5. Okay, my dear children, just only for the understanding. Okay, I am multiplied by 2 and multiplied by 5 because we are well thorough in 11th grade. Am I right? This is a ion electron method balance. Am I right? Already we well thorough. Am I right? The first volume. Okay, just only for understanding. Multiplied by the first equation by 2 and the second equation by 5 means, again I am going to write first equation by multiplied by 2. I am going to write 2Mn2 plus ion plus there having 4H2O. If I multiplied by 2 means 8H2O gives 2, that is MnO4 minus I multiplied by 2 means 2MnO4 minus plus 5 electron multiplied by 2 means 10 electron minus plus 8H plus multiplied by 2 means 16H plus ions. That's about the first equation. The second equation multiplied by 5 XeO6 4 minus plus 2 electron multiplied by 5 means 10, then 6 plus 6H plus ions means multiplied by 5 means 30H plus gives 5 XeO3 plus 15 water molecules. So which are the possible for cancelling? 10 electron cancel. 16 H plus and 30 H plus ions cancel, remaining 14 H plus ions. Then about water 8 H2O and 15 H2O cancel. I am writing here 7 H2O, remaining balance is 7. So what is the remaining here? 2Mn2 plus 5 XeO6 4 minus plus 14 H plus gives 2MnO4 minus plus 5 XeO3 plus 7 H2O. This is about the overall reaction. Try to learn this one. Next about the xenon reacts with PT, platinum, that is hexafluoride. We given yellow orange solid, that is XePT56. Am I right? And about it is insoluble. It is one of the insoluble in carbon tetrachloride. And about xenon difluoride form an addition compound, sum of an addition compound, that is about that XeF2, SbF5, that is antimony pentafluoride, am I right? SbF5 means antimony pentafluoride, and XeF2, and we get 2TaF5, tantalum pentafluoride, tantalum, TALUM, tantalum pentafluoride. Try to learn this one, for sometimes it may be asked about the one-word question. And xenon hexafluoride compounds with the boron and alkali, we get XeF6, BF3, we know that one, boron trifluoride, and also xenon hexafluoride, XeF6, and also we get the MF. That is simply we are writing that one, that is a metal alkali. M refers to alkali metal, am I right? Next, there is some evidence for extensions of the xenon dichloride, that is XeCl2, some of the evidence having. Next about krypton and krypton difluoride. When an electric discharge is passed through a krypton and fluorine at 183 kelvins, 183 Celsius, or when the gas is irradiated with SbF5, it forms Kr is a krypton fluoride, krypton difluoride, KrF2, and also 2SbF3. Okay, 2SbF3. Sb means all of you know that one, antimony. Then some of the structure. We can learn about the sum of the structure of compounds of xenon. How can we, this is also just we are, those who are writing the NEET or examination for JEE or IIT examination, that students is must learn this area, how to thorough this area, what is the structure of XeF2, structure of XeF4, these are all everything you have to learn. My dear children, these are already we learned in 11th grade, just we are recalling here. XeF2, first one XeF2, the number of atom attached to xenon. How much atom is attached to the xenon? 2F, am I right? 2 fluorine atom. So to find the bond pair and lone pair addition, am I right? First, the valence electron of xenon is equal to how much? Xenon, there is valence number of electrons. All of you know that one, it is completely filled, so outermost must have 8 electrons, am I right? So xenon having 8 electrons. Fluorine, that is about the 2 fluorine is there, am I right? The bond pair of xenon fluoride is 2. 1 fluorine is 1, 2 fluorine is 2, am I right? So lone pair calculation. So this is a small method we are going to learn about that. Already we have 8 electron in the outermost shell, so 8 minus here 2 bond pair, 2 fluorine is attached to 8 minus 2 is equal to 6 electron. That is 6 electron means 6 we are divided by 2, that is 1 pair means 2 electron, 1 pair means 2 electron. 6 divided by 2 means 3 lone pair of electron, am I right? 3 lone pair of electron. So bond pair and lone pair addition, we have to learn about that. So we know that one, the bond pair is how much? Bond pair means 2 fluorine atom, that is about 2. What is about the lone pair? That is 3. 2 plus 3 is equal to 5, am I right? The previously I told that the number 2 means Sp, 3 means Sp2, 2 means Sp, 3 means Sp2, 4 means Sp3, 5 means Sp3d, 6 means Sp3d2, 7 Sp3d3, am I right? So we get the answer is 5. 5 means what is hybridization? Sp3d hybridization. And one of the point, what is about the one of the point means actually Sp3d here our expected shape, that is very important. Expected shape means trigonal bipyramidal. Our expected, okay, this is not an actual, it is not an actual expected product. Our expected product is trigonal bipyramidal for a Sp3d hybridization. But Why this shape becomes means we are considering the bond lone pair. I told that about xenon compounds here having how much pair of lone pair? 3 pair of lone pair. Am I right? If you are considering means this shape only trigonal bipyramidal. But if you are not, as per the valence bond electron repulsion theory, as per this theory, we are not considering the lone pair, so we get the shape is linear. So we have to draw the two shape. The first shape is a trigonal bipyramidal. First I am drawing xenon Xe. Here one lone pair, here one lone pair, here one lone pair. Okay, so how much is fluorine is attached here? 2 fluorine, 1 fluorine, 2 fluorine. So here what is the angle? This fluorine to xenon 90 degree. What about this angle? Fluorine to xenon here means here also about 90 degree. Am I right? So if you are join this line means as just like triangle. Am I right? Triangle, one of the triangle. So we are saying triangles. We are saying trigonal. Just like one bipyramidal. Bi means two fluorine is there. Bipyramidal. Okay. Now this is an expected. Second one, I am not considering this 3 lone pair of electron. Just I am drawing Xe, F, Ef. Now what is the angle? 180 degree. So 180 degree means all of you know that one. A linear shape. I am right? Straight line. 180 degree. That is about that what? Linear shape. Okay. You are not considering linear shape. Without considering of lone pair, it is a linear shape. That is about that first compound. Second compound, XeF4. XeF4. Number of atoms. How much atom is attached? 4 atoms. Valence electron, how much? Xenon valence electron is 8. So, how much bond pair is, how much fluorine atom is bonded? 4. So, 4 fluorine atom is bonded. So, xenon having 8 electron in the outermost shell. Outermost shell 8 electrons. Out of the 8, 4 is bonded. Am I right? Remaining have means remaining also having 4. So 4 by 2 is equal to 2 pair having. So 2 lone pair having xenon tetrafluoride. So Xe, there is a xenon having now the bond pair is 4, lone pair is 2. Bond pair 4, lone pair 2. 4 plus 2 is equal to 6. Am I right? So 6 means what is the number? sp3d2 hybridization. sp3d2 hybridization. Actually, if you are considering the lone pair of electron, it is an octahedral. Octahedral. Okay, octahedral. We have to draw xenon. 4 fluorine atom is surrounded. 4, 1, 2, 3, 4. And join here. And again, already I told you that 2 lone pair of electron, 1 lone pair of electron, other lone pair of electron. Am I right? So 2 lone pair of electron. If you are considering the lone pair of electron, the shape is octahedral. Suppose we are not considering these 2 lone pair of electron as per the valence bond electron repulsion theory. We are not considering the lone pair of electron means it is a square planar. What's the shape here? Square planar. Next about that XeF6. Number of electron attachment, number of atom attachment is 6. Valence electron is 8. So 6 atom is attached. Am I right? So bond pair is 6. Am I right? Bond pair is 6. Lone pair is 1. Okay, lone pair is 1. All of you know that one. Here xenon having outermost 8 electron having. Out of this 8, 6 is bond pair. Remaining 1 pair of electron. Am I right? So the lone pair is 1. So the hybridization becomes 7. Am I right? The number is 7. sp3d2 hybridization. Yes or no? sp3d3 hybridization. sp3d3 hybridization. So without considering the lone pair, what is the shape? With considering the lone pair means pentagonal bipyramidal. I am writing pentagonal bipyramidal. Okay. So first I am writing is xenon, 1 fluorine, second fluorine, third fluorine, fourth fluorine, fifth fluorine. This side I am writing one of the lone pair of electron, and above also I am writing 1 fluorine. So I am joining this line. They are having five edges, am I right? 1, 2, 3, 4, 5 edges. So pentagonal, bipyramidal, one of the pyramidal shape. This is the expected one. But if you are not considering the lone pair of electron, this is X is xenon, fluorine, just make it here, down on fluorine, up on fluorine. So here having one lone pair of electron, so just I am mentioning here, lone pair of electron. Here we get one of the distorted octahedral. This is one of the shape for octahedral, distorted octahedral shape. That's about that what? XeF4 shape. Next one about that. Xenon oxyfluoride. Oxyfluoride means how much oxygen is attached. How much oxygen? XeO3 means how much oxygen is attached. 3 oxygen is attached. Am I right? So I am writing Xe, oxygen. How much oxygen? All of you know that one. It is a divalent. Am I right? Oxygen means a divalent. So double bond O. So remaining xenon having 8 electrons outermost. Out of this 8, 6 is bonded. Am I right? Then one more lone pair of electrons. Yes or no? So 3 bond pair, 1 lone pair. So what is number 4 becomes what? sp3 hybridization. sp3 hybridization. What is the expected? Expected means xenon. I am writing xenon. Double bond oxygen. Upper on lone pair of electron. I am fixing on upper lone pair of electron. So what is a shape? That means just like one of the tetrahedral. This is an expected shape, tetrahedral. But we are not considering the lone pair of electron. We are not considering the lone pair of electron. We can be say XeO3. We can be say trigonal pyramidal structure. What's the shape that one? Trigonal pyramidal structure. Otherwise we can be say pyramidal structure. Pyramidal, Pyramidal, pyramidal structure. Next about I am taking what are the use of noble gas means helium. All of you know that one. The helium and oxygen mixture is used for drivers in the place of air oxygen mixture. It prevents the painful dangerous conditions called bends. Second one, it is used for the electrical arc welding of metals. It is used in a cryogenic. Cryogenic means when we are learning in the physics, one of the low temperature science. Am I right? Next also it is used in filling air balloons. These are used of helium, neon. What is about the neon is used as the neon sign. That's one of the electrical sign light. And about the brilliant red glow by passing electric current through neon gas under a low pressure. What is about the organ? Organ is used in the hot filament, also the life in filament bulb. Krypton. What is about the krypton use means it is used in the fluorescent bulb and also flash bulb, etc. Lamp filled with krypton is used in the airport as an approaching light. They can be penetrated through the dense fog. Next about the xenon. What are the use of xenon means? Xenon is used in the fluorescent bulb, flash bulb and also laser. Okay. All of you know about the laser. All of you know that one laser. And xenon emits in intense light and discharge tube instantly. Some of the uses, and also it is used for the photographers, etc. About the radon. Radon is used in the radioactive. It is one of the radioactive. It is used in the source of gamma rays. Radon gas is sealed in a small capsule for used for the some of the disease, some of the medicine they are using, some like that, the cancer growth, like that, the body of in the body to destroy malignants for the cancer growth. Am I right? There are some uses. So try to read this one. So anyhow, today I am giving one of the assignment. What is about the assignment means? Please all of you write the assignment. How is xenon fluoride prepared? Xenon fluoride means first 3 equation. xenon difluoride, xenon tetrafluoride, xenon hexafluoride, XeF2, XeF4, XeF6, and also how xenon hexafluoride reacts with the sodium hydroxide, xenon hexafluoride, XeF6 reacts with sodium hydroxide. That's the equation, only 4 equation. And about the practical section, I will explain you in the next class. Okay, practical, I will explain about how to do the titration. I will explain the next class. Thank you all of you. Thank you. Have a nice day.